Alright guys, it looks like we're in for another semi-long video. This is the very last, I guess you could consider it a lecture video of this chapter. This is section 8.8. We're still talking about trig identities, so I guess this is trig equations, not identities. Trig equations. Version 2.0. Okay, and with this, we have a bunch of different, more different ways that we're going to solve trig equations. Now, the first I want to talk about is solving a trig equation quadratic in form. So we're looking at 2 sine squared theta minus 3 sine theta plus 1 equaling 0 for 0 is less than or equal to theta is less than 2 pi. Okay, now this is a quadratic equation that actually can be factored. You remember with factoring, there's a few different ways to do it, but this ends up factoring out to be 2 sine theta minus 1 and sine theta minus 1. Okay? Now, this is going to be equal to 0. So we want to pull these apart and say that 2 sine theta minus 1 equals 0. And sine theta minus 1 equals 0. Okay, so that means here 2 sine theta is equal to 1. And then sine theta is equal to 1. So this means sine theta is equal to a half. So we have either sine theta is equal to a half or sine theta is equal to 1. Now once again, we're in the interval between 0 and 2 pi. Okay, so for 1/2, we have pi over 6 and 5 pi over 6. And for sine of theta, it is pi over 2. So here are our 3 answers. Okay. Now let's talk about doing an equation based on hey look, I can insert a picture. But we're going to solve a trigonometric equation using identities. Okay, this is actually my classroom at White Oak. So I don't want to do that. I want to just go back to the green chalkboard, and I want to see if I can get rid of this picture. Okay, there we go. So we're going to solve the equation 3 cosine theta plus 3 equals 2 sine squared theta. Okay, and once again, theta is going to be between 0 and 2 pi. Okay, now this is solving a trig equation using the identities. Okay, so basically, using the identities, I want to make it only cosine. So I need to change this sine squared to cosine. So this is 3 cosine theta plus 3 equals 2 times, now changing it from sine to cosine means that sine is the same as 1 minus cosine squared theta, okay, from one of our identities. So therefore we have 3 cosine theta plus 3 equaling 2 minus 2 cosine squared theta. I'm going to bring the 2 cosine squared theta in front plus 3 cosine theta plus 1, because I subtract 2 here and here, equals 0. Okay, so once again we factor this out to give us 2 cosine theta plus 1 and cosine theta plus 1 equals 0. So we have this 2 cosine theta equaling 0, or plus 1 equaling 0. And we have cosine theta plus 1 equaling 0. So once again, like our work, we have 2 cosine theta equaling negative 1 and cosine theta equaling negative 1. So this is cosine theta equaling negative 1/2. Okay, and so for the interval for cosine theta equaling negative 1/2, if you look at our unit circle, that gives us 2 pi over 3 and 4 pi over 3. And when cosine of theta is equal to negative 1, that is just pi. Okay, so here we have our interval, and actually we need to put this in order, so it needs to be 2 pi over 3, 4 pi over 3, and actually in the middle here is going to be pi. Okay, so there, once again, we're solving. Okay, now you can take this a little bit farther. And there's a few other examples in the book that I'm actually going to include when I do the problem example video. But anyway, so now we're moving into example 6, which is solving a trig equation linear in sine and cosine. So we have sine of theta plus cosine of theta equaling 1, and once again, theta is between 0 and 2 pi. Now, sine theta plus cosine theta equaling 1, that's the same as, now we also know, now let's say we square these. So that gives us sine theta plus cosine theta squared equaling 1. Now when we square this, we do sine theta plus cosine theta times sine theta plus cosine theta equaling 1. And then if we FOIL, we end up with sine squared theta plus 2 sine theta cosine theta plus cosine theta squared equaling 1. Okay, now if you remember, sine squared plus cosine squared is 1. So if we subtract sine squared theta plus cosine squared theta, that's the same as subtracting 1. And so therefore, the sine thetas cancel, the cosine thetas cancel, that cancels, so leaving us with 2 sine theta cosine theta, that equals 0. Okay, divide by 2, that gives us sine theta cosine theta, still equaling 0. Okay, so therefore, sine theta is equal to 0, or cosine theta is equal to 0. So sine theta equals 0, cosine theta is equal to 0, because if you take a 0 and multiply it by anything, that still gives you 0. Okay, so since these are 0, that means for sine, theta is equal to 0, pi, and for cosine, it's pi over 2 and 3 pi over 2. Okay, so here we have these solutions. Now, one last thing that we need to do is we need to double check. Okay, now let's first plug in the 0. So we had sine theta plus cosine theta is equal 1. If we plug in a 0, that gives us sine 0 plus cosine 0 equaling 1. Okay, and based on our unit circle, sine 0 is 0, cosine of 0 is 1, and 0 plus 1 does equal 1. So 0 works. Okay, now what if we plugged in pi? So if we plug in pi, we want this to equal 1. Okay, sine of pi is 0. Cosine of pi is actually negative 1, and when you put these together, that does not equal negative 1, so pi is out of the question. Okay, now let's give pi over 2 a shot. Okay, so pi over 2, pi over 2. Now sine of pi over 2 is 1, cosine of pi over 2 is 0, and this equals 1, so that works. Now, last but not least, let us try 3 pi over 2. Now, if we plug this in, this gives us negative 1 plus 0, and that does not equal 1, so that does not work. So our two that work are 0 and pi over 2. So, ladies and gentlemen, that actually ends our video for today. Kind of shorter than what I was thinking. But, short, sweet, to the point sometimes is always good. Like I said, those other two examples I'm going to include when I do the video for our equations. Once again, thank you very much for your time and patience.